Let's take up question based on hydrocarbons. The first question is, how will you convert ethanoic acid into benzene? First step is ethanoic acid. We are reacting with NaOH to form sodium acetate. Sodium acetate on heating with soda lime is NaOH plus CaO, will result in the formation of methane, and this reaction is called decarboxylation because CO2 is lost. Then we are treating it with chlorine in presence of sunlight. Free radical substitution reaction will take place and we will get chloromethane. Now from chloromethane we want two carbon atoms because ethanoic acid contains two carbon atoms, and benzene also can be obtained from acetylene which contains two carbon atoms. So we are carrying out Woods reaction. And speciality of Woods reaction is their carbon atoms will become double. So 2 moles of CH3Cl when react with sodium metal in presence of dry ether as a solvent, we get ethane. Ethane is treated with chlorine in presence of sunlight, undergoes free radical substitution reaction to form chloroethane. Chloroethane is treated with alcoholic AOH. Elimination reaction takes place. Cl from here and H from another carbon will be lost. HCl will be lost. That is, dehydrohallucination will be taking place, and you will get CH2 double bond CH2. Alkene is formed. This reaction is called nucleophilic elimination reaction. And alcoholic AOH means we have ethoxide ion which can abstract H positive ion from beta carbon. That is, the carbon which is attached to chlorine is called alpha carbon. The next carbon is called beta carbon. So this reaction is also called beta elimination. Ethene is reacting with bromine and undergoing electrophilic addition reaction to form 1,2-dibromoethane, which on treatment with alcoholic KOH gives bromoethene. Common name of this compound is vinyl bromide. Here also elimination reaction is taking place. Br from here and H from here, that is HBr, is removed and we get CH2 double bond CHBr. Then we treat it with NaNH2, that is sodamide, which behaves like alcoholic KOH because NH2 negative is strong nucleophile, and again it will carry out elimination reaction. HBr will be lost and double bond will change to triple bond and we get acetylene. 3 moles of acetylene when passed over red hot iron tube, it undergoes polymerization or trimerization to give benzene. That is the way how acetic acid can be converted into benzene. And if we want to prepare any benzene derivative, then we can start from benzene and prepare corresponding derivatives. Here this reaction, this method requires lot of steps. We can use alternative method also. Alternatively, first we reduce ethanoic acid to ethyl alcohol with the help of lithium aluminum hydride, and then with the help of concentrated sulfuric acid at 433 to 443 Kelvin carry out dehydration to form ethene. And further reactions are same, that ethene will be changed to 1,2-dibromoethane by adding bromine. Then we'll add alcoholic KOH, we'll get vinyl bromide. Vinyl bromide with NaNH2 will give acetylene, and 3 moles of acetylene on polymerization will give benzene. So this method is comparatively shorter. We can use this method also. Next we are going to take up IUPAC name of the following compounds. First we select the longest chain possible. 1, 2, 3, 4, 5. This is the longest chain possible. With the second carbon, 2 methyl groups are attached. With the fourth carbon, 2 methyl groups are attached. So we write 2, 2, 4, 4. Total 4 methyl groups are there. So we are writing tetramethyl. The number of carbon atoms in the longest chain are 5, so we call it pentane. 2244 tetramethyl pentane is the IUPAC name. Next compound we are going to name. Here also first we find the carbon chain 1, 2, 3, 4, 5. Now here we have side chain which are longer. This is tertiary butyl in common system. So we call it 3,3 ditertiary butyl. because this group is called tertiary butyl and this name will be accepted in IUPAC system also. So we call it 3,3-di-tertiary butyl 2,2,4. At second carbon there are two methyl group and fourth carbon there are two methyl groups. So 3,3-di-tertiary butyl 2,2,4 tetramethyl pentane. This is the IUPAC name of this compound. In this compound, we count first, second, third, fourth, fifth carbon atom. And with the third carbon, there are two methyl groups, so we call it 3,3-dimethyl pentane. That is the IUPAC name of this compound. Next, we are taking, write the structural formula of the following compounds. The first one is 3,4,4,5 tetramethylheptane. So first we write 7 carbon atoms, 1, 2, 3, 4, 5, 6, 7. With the third carbon we add methyl group, with the fourth carbon we add 2 methyl groups, and with the fifth carbon we add 1 methyl group. This compound is 3,4,4,5 tetramethylheptane. Next compound, again we count the carbon atoms 1, 2, 3, 4, 5, 6. With the second carbon there is methyl group. With the fifth carbon there is methyl group. So this compound is 2-2-dimethyl hexane. Next we are taking, write the structure for each of the following compounds. Why are the given names incorrect? Write the correct IUPAC name. These are typical examples. Now here longest chain starts from here and it contains 6 carbon atom and not 5 carbon atoms. So don't think that straight chain will always be in straight line. It can be it may not be in straight line, but you have to see the longest chain 1, 2, 3, 4, 5, 6. So here longest chain contains 6 carbon atoms and at third carbon methyl group is attached. So correct IUPAC name is 3-methyl-hexane and not 2-ethyl pentane. Next we have this compound where methyl group is at fifth carbon and ethyl group is at third carbon. But it is written 5-ethyl and 3-methyl heptane. Alkyl groups are preferred alphabetically, so ethyl should get lowest number, third carbon, and methyl should get fifth number. So the correct name of this compound is 3-ethyl 5-methyl heptane. The rule is alkyl groups should be preferred alphabetically. Next we are taking sodium salt of which acid will be needed for preparation of propane. Write down the chemical reaction for it. Here there are two possibilities. If you take sodium butanoate and heat it with soda lime, NaOH and CaO at 630 Kelvin, Na2CO3 will be lost and propane we will get. There is another possibility that we take sodium salt of 2-methyl propanoate and heat it with soda lime. Again Na2CO3 will be lost and we will get propane. So these are two compounds from which on heating we can get propane. Let's take up IUPAC name of the following compounds. First, we write expanded formula which helps you to count the number of carbon atom. Longest chain contains 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. There are 10 carbon atoms in longest chain. With second carbon we have methyl group. Then we have 8th carbon also we may have methyl group. So we call it 2,8-dimethyl. Total carbon atom are 10, so we write deca. After third carbon atom there is double bond. After sixth carbon atom there is double bond, so we call it 3,6-diene. And if you count all the single bonds, there will be 33. Pi bonds are 2. The double bond contains 1 sigma bond and 1 pi bond. So there are 2 double bonds, so it will contain 2 pi bonds. Next example, we have this compound. We have to start counting from this corner. 1, 2, 3, 4, 5, 6, 7, 8. Total are 8, we write octa. Double bond is after first, third, fifth and seventh, so we write 1, 3, 5, 7. Tetra means 4, ene means double bond. So it is called octa 1357 tetraene. This compound we want to name. First we will find out the longest chain. 1, 2, 3, 4, 5. Longest chain must contain double bond. That's why this chain has been taken and not this chain of 7 carbon atoms, because it does not contain double bond. So the functional group containing or double bond containing longest chain contains 5 carbon atoms. This group is left, which is at second carbon. We call it 2-propyl. Pent-1-ene is the IUPAC name. Sigma bonds are 23, pi bond is 1. Next compound we are taking here, longest chain we have to start from this side so that the substituent carbon attached to substituent get the minimum number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. With the sixth carbon there is a methyl group. With the fourth carbon there is ethyl group. So what we write 4 ethyl. First we write 4 ethyl. Then we write 2,6-dimethyl because second and sixth carbon atom contain methyl group. Dec means 10 carbon atoms. For after 4 there is double bond. So we write dec 4-enes. Sigma bonds are 41, pi bond is 1. Next we are writing the structure and IUPAC name of different isomers of alkenes corresponding to C5H10. The first isomer will be pent-1-ene. Why pent-1-ene? Because double bond is after first carbon atom. Let us shift the double bond after second carbon atom, so we'll get pent-2-ene. Third isomer is branch chain, 4 carbon atom in straight chain, methyl group at the second carbon, double bond is after first, so we call it 2-methyl-but-1-ene. Now we shift methyl group to the third carbon atom, so this will become 3-methyl-but-1-ene. Last isomer, here double bond we have shifted to the second carbon, methyl group remains at second carbon, so we call it 2-methyl-but-2-ene. These are 5 isomers of C5H10 and all are alkenes. Although cyclic isomers like cyclopentane, 1-methyl-cyclobutane are also possible, but isomeric alkenes are 5 structure formula we have given.